All right, so similar set of problems, right? We've got a times x to the n power. Notice in all of these, I have odd exponents, so n is odd. We also know that there's a 1 in front of all of these, so we know that a is positive. So a is greater than 0, and n is odd. So if we look at the end behavior of these graphs, we can see that on this one, as x goes to the left, so as x goes to negative infinity to the left, we know that my y values go downwards, also to negative infinity. And then up here, as x goes to the right, as x goes to positive infinity, my y values will end up going upwards as well. So notice how my f of x values are different this time, right? They have different end behaviors, okay? So when we look at the shape of this, all right, we are going to say that it is increasing. All right, now when I say increasing, you could have a cubic function or a fifth degree function that goes like this. So it's not increasing necessarily the entire time, but in general, we start in an increasing pattern. All right, so regardless of what happens in the middle, we know that over time, from the beginning to the end, it is increasing. All right, it'll go up over time. So increasing. And this is because a is greater than 0. So whenever a is positive, it will increase like this over time. We can also say that the higher the degree, the flatter it looks, right? You can see that if I've got x cubed, it's a little smoother here. And then when I get to x to the 9th, that's kind of this flat kind of boxy look here. Again, now this only works when I've got a times x to the n power. Once I start adding on other things, this rule doesn't necessarily apply, right? If I have a bunch of extra stuff here, it's not always going to look that flat. But in this general form, we do notice that pattern. That is something that you might notice. And then we also notice the last thing is that f of x has different end behavior, right? Here it goes to negative infinity, but over here on the right, it goes to positive infinity. All right, and then down here, very similar situation. You could probably guess it would have looked like this. Here, a is negative, and n is still odd. Right, these are still odd exponents. And so if we look at the end behavior, we can see that as x goes to negative infinity to the left, my y values will go up. And as my x values go to the right, my y values will go down. And again, notice the same things. In general, we're going to say that this is decreasing when a is less than 0. Again, it might have a few little curves in between, but in general, it will go down from the beginning to the end. All right, that's always going to be true for these types of functions. And then we can actually take these two statements here, and we can bring them in right down here. So go ahead, copy paste those two statements. Those will still be true for this shape. The higher the degree, the flatter it will appear. And we know that f of x has different end behaviors because we can see that when x goes to negative infinity, my y values go up to positive infinity, but over here my x values will go down.